Today we're going to look at the law of constant composition. It is also known as the law of definite proportions. The law of constant composition states that the chemical composition of a pure compound is always the same regardless of the source. It's always the same. Now, let's look at a molecule of the compound water. Now we know that the atomic mass unit is given in terms of U, right? So for this particular molecule, if we look at water, there's oxygen, that's hydrogen, and that's hydrogen. In terms of atomic mass units, we know that hydrogen mass is equal to 1 U, and we've got 2 of it, so the other hydrogen is 1 U, and oxygen is equal to 16 U. So in total, the molecule has a mass of 18 U. And we also know that the U, the atomic mass unit, is equal to 1.67 times 10 to the minus 24 grams. Right. As you can see, the number is very, very small, so we just dealt with atomic mass unit. So instead of saying that the mass of one molecule of water is 18 times 1.67 times 10 to the 24 grams, we just use the atomic mass unit and said it's 18 U for the molecule H2O. Same thing with hydrogen peroxide. We have hydrogen peroxide is H2O2. There we have H, oxygen, oxygen. And we know that we have 2 hydrogens, so that would be 2U plus 2 oxygens, and each one is 16U, so that would give us 32U, and that is then equal to 34U, or atomic mass unit. That is the mass of one molecule of hydrogen peroxide. And to get its absolute mass, we then take 34 and multiply it by 1.67, which is given to 2 decimal places, times 10 to the minus 24. But if we look at water, we notice that in terms of water, it has 1 oxygen and it has 2 hydrogens. So water will always have that composition. It has 1 oxygen and 2 hydrogens. The composition remains constant. And it's the same thing, like, for instance, if I ask you what is the gender composition in your class, you may have 2 boys and 3 girls. That's the gender composition. All right, so here in this situation, we're looking at an elemental composition. And the composition of peroxide is also constant. That means hydrogen peroxide will always have 2 hydrogen atoms and 2 oxygen atoms. Now, these are the atomic masses, but we are not going to be working with the atomic masses. We are going to be working with the the relative atomic masses of these molecules. Why relative? The masses of these molecules of these elements are relative to the mass of 1/12 of the carbon atom. And being relative to 1/12 the mass of the carbon atom, the units cancel out, and then it is we only use the number. Let's look at the periodic table. You'll see here you are given the approximate relative atomic masses, right? Most of these are given as whole numbers. Normally, these atomic masses are given to 3 and 4 decimals. However, we have chlorine, which is given as 35.5, and we got copper given as 63.5. The rest are given as whole numbers, as we are more interested in the concepts than really giving the values in terms of 3, 4, 5 decimal numbers. That becomes more relevant if you go into higher chemistry and you want more accurate results. Now, let's look at an exercise. It says, determine the relative number of atoms in the molecule or the formula. So remember, in certain cases, like when we had a molecular solid, we had a discrete molecule. When we had an ionic solid, we found that we do not have discrete molecules, but for example, in sodium chloride, the ratio of sodium to chloride ions, sodium ions to chloride ions was always 1:1, and so the empirical formula for that was NaCl. So that's why I have written here atoms in a molecule or formula unit. So when we're dealing with a molecular solid, it's molecule, and when we're dealing with ionic substance, we tend to use the word formula unit. Right, now let's look at, then we're looking at the elemental composition. We want to know what elements it's made of. So if we look at CaCl2, you'll notice that it has one Ca and it has two Cl atoms. So the ratio of Ca to Cl is 1:2. And that will always be the case for calcium chloride. There will always be one calcium and two chloride atoms in a formula unit of calcium chloride. Let's look at the elemental composition of calcium chloride. Right. Now, if we want to know the relative formula mass of calcium chloride, but for now I'll use terms interchangeably. We'll talk about the formula mass or the molecular mass, the relative molecular mass, or the relative formula mass. And if you look at calcium chloride, and I'll use a symbol, let's say M. Let's do this. So M, R for relative, we know that it doesn't have a unit, and that we want the relative mass of CaCl2, and that is given in terms of the sum of the relative atomic masses. So that would mean AR, the relative atomic mass of calcium, plus the relative atomic mass of Cl. Now let's just do this properly. Since we have 2 atoms of chlorine, so it will be 2 times the relative atomic mass of chlorine. Right, now if we go to the periodic table and we look at the relative atomic mass of calcium, and we need the relative atomic mass of chlorine. So if we look at calcium here, the relative atomic mass is given as 40, and if we look at chlorine, so that's calcium, and if we look at chlorine, we see it's 35.5. Now here we then have that is equal to, that's equal to 40, right? And if had we made wanted in atomic mass units, then it would have been 40U, but we just dealing with relative atomic masses, plus 2 times 35.5, which would then be 40 plus 71, and that is equal to 111. So the relative formula mass of CaCl2 is equal to 111. Now if we want now the percentage composition of each of the elements in this molecule, so we say percentage of calcium is equal to 40 upon the total relative mass times, we want a percentage, and that is equal to 36%. And the relative, the percentage of chlorine is equal to 71.11, and that gives us 64%. And that is the elemental composition. Calcium makes up 36% of the mass, and chlorine makes up 64% of the mass. it's like saying if I have 100-gram sample of this calcium chloride, 36 grams would be calcium and 64 grams would be chlorine. Let's go to the next one. Here we have Al, aluminium chloride, and if we look at M of aluminium chloride, and that is equal to the atomic mass of aluminium plus 3 times the atomic mass of chlorine, which is then equal to, let's go to the periodic table. All right, and if we look at aluminium, the mass is 27, and if we look at chlorine, it's 35.5. So that would be 27 plus 3 times 35.5. All right. 35.5, which is then equal to 27 so it's equal to that, which is then equal to 27 plus 106.5, which is equal to 133.5. Alright, so if you want the elemental compositions, now that we know the formula, the relative formula mass, which is one of AlCl3, which is 133.5, we can now work out the elemental composition. So percentage of aluminium would be equal to 27 times, and that gives us 20.2%. And if you want of chlorine, which is chlorine, which is 106.5 upon 133.5, like that, and that gives us 79.8%. Let's go to the next one. Here we got H2SO4, and you may recognize it. This is sulfuric acid. So M of sulfuric acid, and as you can see, these are all nonmetals which we spoke about in our earlier lesson. So it gives rise to a molecular solid, and here in this case it would be more appropriate to refer to it as a relative molecular mass, but it doesn't really matter. So we have H2SO4, which means in this case we have now, which is equal to AR is equal to, well, we got two hydrogen atoms, so 2 times AR of hydrogen plus AR of sulfur plus 4 times AR of oxygen. Well, hydrogen we know is 2, and the relative atomic mass is 1, plus sulfur. Let's go to the periodic table, and if we look at sulfur, sulfur here is 32, and we know oxygen is 16. So sulfur is 32 plus 4 times 16, which in total is equal to 2 plus 32 plus 64, which is 98. If you want to determine now the percentage composition, we say percent composition of hydrogen is equal to 298 and that gives us 2.1%. If we look at percentage of sulfur, would be 32 upon 98, and that is equal to 32.6%. Let's see the percentage of oxygen is equal to, we know we had 64 upon 98, and the same routine we're going through, and that gives us 65.3%. Right, so in terms of sulfuric acid, 2.1% is hydrogen, 32.6% is sulfur, and 65.3% is oxygen, which also means if I've got a 100-gram sample over here, 2.1 gram is hydrogen, 32.6 is sulfur, and 65.3 grams is oxygen in there. HCl, molecular solid also, so it's made of discrete molecules of HCl, which then gives us right of HCl, and which is equal to AR of H plus AR of Cl, which is then equal to 1 plus 35.5, which is then equal to 36.5. And if you want a percentage of hydrogen, which would be 1 upon 35.5 times 100%, which will give us, which is equal to 2.7%. And percentage Cl is equal to 35.5 upon 36.5 times 100%, which will give us 97.3%. So it gives us, which is equal to, I'll put it down here, which is then equal to, which is equal to 97.3%. Let me just see this here. So this is actually 36.5. Right, so there's the composition of our hydrochloric acid. Now let's look at CH4. CH4 also, if it forms a solid, then it's a molecular solid. So we have CH4, and that is equal to AR of carbon plus the relative atomic mass, but 4 times, since we got 4 hydrogens, 4 times, so plus 4 times the mass of hydrogen. And if we look at this is then equal to carbon is 12 plus 4 times 1 of hydrogen, which is then 16. And if we want now the elemental composition, we've got percentage carbon, which is equal to 12 upon 16 times 100%, which gives us 75% carbon. Oxygen would then be where I'm going for oxygen. Hydrogen is then 4 upon 16, and that gives us 25%. Let's look at sodium bicarbonate or sodium hydrogen carbonate, right? Which is sometimes also called bicarbonate of soda, and you know this particular ingredient is used a lot in baking. So here we have M of Na hydrogen carbonate, and if you look at this, and the AR of Na plus AR of H plus AR of C plus AR of O, but we got 3 of it, so it's 3 times the AR of O. So if we look at, we want the mass of sodium, and we look at the periodic table again, right? And if we want to look at the periodic table there, you'll see I've got sodium, which is 23. Right? The atomic mass of that, okay, so sodium, so this is equal to then 23 for sodium plus 1 for hydrogen plus 12 for carbon, and oxygen is 3 times 16, which means it's equal to 23 plus 1 plus 12 plus 48. And that gives us 84. If we want now the percentages of Na, that would be 23 upon 84 times 100%, which would be 27.4. And the percentage of H is equal to 1 upon 84 times 100%, which gives us 1.2%. You'll notice I'm giving all these to one decimal place, and then percentage of carbon is equal to 12 upon 84 times 100%, which gives us 14.3%. And then percentage of oxygen is equal to 48 upon 84 times 100%, which gives us 57.1%. Okay, 57.1%, And let's look at this one here now. Here we got iron sulfate, and in iron sulfate we have M of Fe2SO4, right, in brackets 3. So we know that if we want the AR for this, AR would be of Fe, let's just get back there again. This is 2 times AR of Fe plus 3 times the AR of S plus 12 times the AR of O. AR of O. AR of O. Right, you may say, how have I got that? If I have, for instance, FeSO4 like that, 3 Fe2, what this really means, I got Fe plus another Fe, and I've got 3 SO4s, which means SO4 plus SO4 plus SO4. So it's 1, 1, 2, 3 there, and it's 4, 8, 12, so it's 12 there, right? Okay, so our AR for this would be AR for Fe, but 2 times that plus 3, oh no, I've got it there on top, so I don't know why I'm repeating it. So that would be 2 times, and Fe is equal to, the mass is 56, right, plus sulfur is 32, so it's 3 times 32 plus oxygen is 12, right, times 16, and that in total is equal to 400. If we want now the percentage composition of Fe, that would be 2 times 56 is 112, which gives us that, times 100%, which gives us 28%. And then sulfur percentage is equal to 96 upon 400 times 100%, which gives us 24% for sulfur. And for oxygen, it's equal to 192 upon 400 times, and that gives us 48%. And that gives us 48%. And there we have it, right? So, which means that iron sulfide, 28% is iron, and 24% is sulfur, and 48% is oxygen. Which I mean, if I have a 100 gram sample of this of iron sulfate, it would mean that in there I have 28 grams of iron, I've got 24 grams of sulfur, and I have 48 grams of oxygen in there, right, within that compound. Okay, there you have it. See you next time.